comprises, okay. The hardware platform comprises sensors and electronic modules and diagnostic station. So as you can see here, we install only one sensor per bearing shaft. And this sensor monitors and measures different vibration parameters, including analog vibration signal in wide bandwidth. It allows the system processing this signal and identify what particular failure can happen if nobody remove destructive forces which applied to this particular piece of equipment. We got 80% of information from vibration, but not only. Also, depending on machine, we utilize different non-destructive methods and measure different parameters such as current, eddy current, temperature, pressure, etc. It depends on particular machine. Then, after we install the sensor, we combine 8 sensors to one module. We connect to one module, 8 sensors, and then connect module to each other, and only one line goes to the control room. In control room, we located a diagnostic station, which processes the signals, analyzes them, and delivers prescription to the personnel what should be done to prevent the failure. So, artificial intelligence of the system identifies almost all malfunctions and defects in rotating equipment and in static equipment, but I'm talking right now only about rotating equipment. As you can see here, there is a list of defects and malfunctions in centrifugal machines on the left, and in reciprocating compressors on the right. As you can see, almost all, most often defects can be recognized by the system automatically with an accuracy more than 97%. So how a system does it? The system measures, as I mentioned earlier, different parameters of vibration signal, provides real-time FFT, and then identifies bench of parameters which are evidences of one of 3 classes of defects. System identifies 3 classes of defects. This is a high-frequency defects, which are related to process mode or bearing defects. The mid-frequency defects, which are related to misalignment and debalancing. And low-frequency defects, which are related to fastening, to basement, to low-frequency defects. So then, after system identifies the class of defects, system selects the algorithm to identify the particular defect. When the system identifies the particular defect, system compares the amplitude of the feature of defect with the library of thresholds. Each defect has own library of thresholds, and system knows exactly what kind of defect happens and what kind of stage of degradation is. If system doesn't identify the particular defect, at least system identifies a class of defect and can focus the attention of the personnel on the particular class of defects. However, if you allow us to connect the DCS to the COMPACS system and to get process data from DCS to the COMPACS system will find correlation between process parameters and parameters of technical state. And according to this correlation, system can identify the source of defect and malfunctions. So there are 3 possible sources. This is a process violations, this is a fatigue deterioration of equipment, and the third one is poor maintenance. So Depending on source of equipment, particular department can react accordingly. If this is a case of a process violation, of course, operators have to be involved in reliability, and they have to reduce destructive forces which began to influence the weakest part of equipment. So they have to slightly change the process mode to extend the lifespan of this particular piece of equipment. The third component of the system is the software platform. Here you can see the monitor mode. In the middle of the left, you can see different sections of the unit. It could be facility or unit. There are several pump houses here. And you can see that the first called pump house is an unacceptable condition. And the system points this pump house as a pump house with equipment in worst condition. Then you can see here the equipment within this pump house. You can see that there are 2 pumps with unacceptable condition and 3 of them in action required. So system, if we put cursor on any pump, you can see what kind of particular parameters system measures and what kind of particular prescriptions system issued to solve the problem. So system focus your attention on most important pieces of equipment right now. Most important means most vulnerable. And of course, in that case, when you know exactly what defect happened, you can carry out nearest urgent actions to eliminate this defect development. Besides the diagnostics, the COMPACS system calculates residual lifespan. So operators and maintenance department know exactly how much time do they have to fix the problem. And it allows maintenance department sleep very quietly without any in calmness during night and weekend, because they can carry out all necessary actions before weekend starts. So they can maintain the system, the equipment earlier in advance if it requires to be maintained. On the other hand, operators also carry out the process, conduct the process very, how can I say, with no doubts, because they know exactly how the process mode changed when they affected the equipment state. And if they did something wrong, they will be informed immediately, because the system closed the gap between process mode changes and technical state of equipment. So operators always know what's going on and they know how to react. The system can be connected to any other systems in your facility. It could be DCS, it could be PI. It depends on your requirements. It depends on your information policy. Besides the monitor mode, system has other different modes, such as analysis mode, which you can use to identify root cause of failures, to confirm or to make more detailed the system's prescriptions. Also, there is a trend mode. System records all measured parameters in 5 databases from real time to 9 years. And this is a system mode. This is a self-diagnostics mode. So the system diagnoses itself and each component of the system, if it works properly or fails and if it fails, system issues prescription to check the channel or check the sensor or check the line, etc. System has the report mode, where you can find several standard reports about equipment technical state, or you can create on-demand report. Usually, people use these reports for justifying the maintenance order. If you want to justify maintenance order, you just attach this report to maintenance order, and manager knows exactly what's going on with particular piece of equipment. It doesn't need to double check or believe to somebody. It just shown this particular piece of equipment required to be repaired. That's it. But the compact system, this is only the tool. To be able to use this tool is most beneficial manner, we have to introduce you the real-time, our technology of safe resource-saving operation and maintenance of machinery. As you can see here, the compact system monitors equipment, delivers prescription to operators according to which operator changing the process mode and extend the uptime of the equipment. Also, operators commissioning the machinery after repair or maintenance only with high potential residual life, because the compact system provides unbiased assessment of technical state while the machine comes from maintenance. On the other hand, maintenance department has exact information about what's going on with equipment, what kind of repair or maintenance requires to be carried out. They could figure out a root cause of failures. They can identify if these failures come from fatigue deterioration or from operators misbehaving. And all this information and all involvement, all parts involvement in the reliability process is transparent for management. So each person who are involved in reliability and maintenance and operations became on the same page since the system is installed in the facility. On this slide, I'd like to grab your attention for key performance indicators of one of our customers in compare with the global best KPI according to reliabilityweb.com. As you can see here, there are 5 key performance indicators, and all 5 of them are better with the compact system installation. Especially, my proud is the 5th key performance indicator, available time. So one of our customers using our system and implemented our technology of safe resource saving operation and maintenance of machinery, went through 3 steps of improvement. So first step is eliminating existing problems. The second step is figuring out the root causes and eliminating the root causes. And third step, figure out the bottlenecks and eliminating bottlenecks of facility operation. Bottlenecks, this is something which limits the facility uptime. And then after that, they reached 3.5 years of non-stop, non-shutdown operations, when before those activities have been carried out, they stopped for maintenance every year for 30 days. So for 3.5 years, they added 100 days of operations. This is a significant amount of money. And this is what do we working for. So what do we offer? We don't sell the system as is. We sell the system as a service. It means that we develop the turnkey system, develop the system on turnkey basis. So initially, our engineers study your equipment, develop, get your approval on this project, then we manufacture the system, we supply it to a site, Then you hire contractors who install the system at the equipment. Our engineers supervise installations. Then they commission the system. After that, they training your staff, your operators, and your maintenance team. And after that, we provide the service. It means that we support your reliability activities as well as we maintain the system during subscription period. You pay annual subscription, and during this time, maintenance of the system will be our headache. So you don't pay for anything. You just focus on your equipment and on the system's prescription. That's it. If some component of the system failed, we substitute it for free for you. Okay, so for each first new customer, we do offer pilot project. Pilot project means that you pay only for hardware, you don't pay for any subscription. And first 6 months, we support your activities in reliability improvement. And in 6 months, you have to admit either that the system is useful or you shouldn't use it. And if you admit that the system is useful and you want to get benefits from the system at your facility, you start to pay subscription. So it's very attractive offer, because it allows you to equip with system not just major large compressor or turbines. It allows you to equip with the system entire processing facility, or at least processing unit. That's it. I'm finished, and I'm happy to answer your questions.
I have a question about your system. Is your system doing the recommendations and doing analysis according to a software in your system, or you you have an access for the system from your office, and you provide a similar some kind of advice about what should be done for according to the scenario of monitoring for the equipments?
Okay. Okay. System send prescriptions automatically without any additional support. This is system's advantage. We don't need some interpreter who will interpret the vibration readings. System works automatically and 24/7. So you don't need to sleep at the facility and to sit on duty during weekends. But the system doesn't provide the particular details what you have to do to reduce the destructive forces or prevent the failure. System identifies failure and send prescriptions what you have to check, what you have to pay attention to. For example, check misalignment, check looseness. But what kind of looseness? System doesn't explain. And in this case, we provide some instruction, some user manual, what we recommend you to check when you see the prescription, check looseness. Or what do we recommend you to check if you see prescription, check misalignment, on check cavitation, or check bearing. There are a list of defects and malfunctions, as you can see here, that system identifies. And then, after identifying these malfunctions, system send prescription what you have to check for.
But without any actions.
Not, of course. Of course, this is automatic diagnostics. The system doesn't know how you to reduce the problem, for example, reduced destructive loads. For example, in cavitation doesn't happen in a second. In cavitation, for example, system issues prescription that check cavitation. What does it mean? It means that operator should check level in a tower and maybe a little bit increase level to reduce the cavitation issues possible. So, but the system doesn't inform what they should do. System informs what problem should be handled.
Mm-hmm.
But of course,
if you have
system has analysis mode, and if you have, for example, if you have subject matter expert in vibration analysis, this expert can take a look more deeply and deliver more detailed explanation of what's going on.
But if you have a limitation for the upper limit and lower limit for your readings, and so we need an action for shutting down the equipment or shutting down the station for to avoid any more destruction for the internal parts. So I think your system don't have this kind of actions. They just give instructions, right?
Look, of course, because we are talking about early diagnostics. You right now you are talking about protection system,
yes,
which shut down a machine. But our system monitors machine when the nonlinear wear of equipment even doesn't happen yet. So you have enough time. You have enough time to react. You have enough time to reduce the destructive forces. You can see here residual life 22 hours. It means that you can carry out special actions. For example, if it bearing problem, you can change lubrication at least. You can for example, if this is a looseness, or you can tighten the bolts on the basement. So you can carry out any urgent actions without shutting down the machine. You don't need to shut down the machine to perform some actions. The same situation with cavitation, as I mentioned earlier. When system identifies cavitation, the first which should be done by operators is the check level of liquid in the tower. And if the liquid level in the tower is low, it should be increased. And in this case, you eliminate destructive forces from the equipment and you extend the equipment's lifespan. You can prevent even repair and maintenance, not just failure. This is main idea of our tool, of our solution. Our solution doesn't execute any actions, but our solution informs you how you can avoid failure.
Okay, it's clear now. Okay, of course, all equipments we have here is should have a requirement for this kind of systems. But of course, the budget is very a major item for this. So if I think about applying or providing this from the management, of course, I will have a priority for the most critical comments. But also, as I see from your equipments, if I make all the system as applied for the whole station, even for one station, but the whole station, I will make a monitoring very clear about the station. So what kind of choices I should have? I should have applied for the whole station, or I should apply for just only the most critical one?
For whole station, of course, because your company makes money from the station operation. not from compressor operation.
Mm-hmm.
And we provide very, very low price for hardware
Mm-hmm.
that you can justify these benefits for your financial departments. Another important thing that financial departments don't calculate profit per machine. They calculate profit per facility.
Mm-hmm.
And of course, if you choose some station, they can easily identify after the system installation if it became more efficient or less.
Mm-hmm.
So there are four sources for economic benefits. The first source is increasing uptime.
Mm-hmm.
So if you, for example, maintain your pump station every year for example, for 2 weeks or for 1 week, it means that during this year, this station doesn't produce money.
Yes.
And if you can extend this period from, for example, from 1 year to 2 years, you add additionally 7 days of operation and 7 days of making money. This is the first source. The second source is reducing shutdowns, sudden shutdowns, downtimes. For example, you have usually you have during the year you have 1 week of downtimes, but using our system you can prevent those downtimes and you can save additional 7 days of downtimes for making money.
Mm-hmm.
The third source, because sometimes due to sudden equipment failure, there is an accident. And during accident, some machine collapses, some station fires, etc. And last one source is the maintenance. Because if you maintain at early stage of degradation, you spend less money for less maintenance.
Mm-hmm.
So there are 4 sources. But why I'm forcing you to choose the SUM facility? Because another reason is that the best way to justify investment is to deliver numbers on the table in front of my financial department. How can you do that? You can do that only if you demonstrate how the facility became more safe, saving more money, and increasing the uptime. So had better to select one facility. It could be, for example, your processing plant, or it could be one platform, but it should be entire facility. Otherwise, you cannot justify, even if system diagnoses the problem of compressor and what else. And they say, okay, this is you have major equipment, you have most critical equipment, you can equip with the system those critical equipment, but you will have 90% another equipment which will make the same headache to you. The same, because if they would be so critical, they wouldn't be installed in the facility. If facility has some equipment, this equipment is critical. Criticality comes from the price of diagnostics. Our solution allows you to get very attractive, very low prices per machine. It's very attractive. And this is the reason why it allows you to equip entire facility, not just one large compressor or one, for example,
one piece of
water
equipment.
pump.
Yes.
Yeah. This is our idea, and this is our business model.
Yeah, you
To
already
be able to provide affordable operation, affordable diagnostics, we deliver the subscription to you. We don't charge you for 100% of money since the first day.
Okay. So you mentioned that you provide the system for the whole condition monitoring equipments like vibration, like thermography, like ultrasound, like current degradation or current kind of current issues. So you can apply all these equipments on your system, or you're just doing it as a software, or hardware, and or both of them.
There are two solutions.
Mhm.
There are two solutions. First is solution for rotating equipment. Only pumps, compressors, air coolers, blowers, exhausters, gears, motors, etc. So everything which spins, turbines, etc. And another solution is for static equipment. Static equipment such as heat exchangers, vessels, tanks,
Separators.
pipelines, etc. Yes, yeah. In this case, system identifies cracks. System identifies a preliminary. When you don't see crack, system will identify the location where crack will happen if you don't carry out some actions. The second important defect, this is a processing mode related defect, because sometimes operators violate SOP, and finally they, for example, fill out the tank more quickly than it required to be filled out. Or, for example, they are deliver more pressure or more floor, more strong flow. Yes, all these violations affect the technical state of static equipment, and system monitors it. And if it happens, system informs operators first, maintenance second, managers third. And everyone knows who is accountable for such situation. Is it poor maintenance, or this is a process violation? And the third one, this is the leakages and contaminations in heat exchangers. So the system identifies time point when more economically efficient to shut down and clean the heat exchanger than continue operated. So you can clean it not when it's scheduled, but you can schedule the cleaning according to system prescription. In our YouTube channel, you can see the short movie about the case with the heat exchanger. So just visit in our YouTube channel and take a look. It's very interesting.
Okay.
So if you want me to present the pilot project for your specific facility, just figure out what kind of facility you want to select, send me data sheets on equipment of this facility, and I'll prepare the case study, and then I introduce it to you first. And if you suggest that it works, it can work, I can come to your site and introduce this pilot project to your management.
That's very
with
good.
you together.
That's very good. Okay. First of all, I want to be specific about what kind of tools you are going to use as a hardware for monitoring for the leakage, for the monitoring for the vibration, for the monitoring for the current, all of these. So what I understood from your words that you are applying all kind of condition monitoring tools as in your the hardware and according to each equipment individually. That's
Of course, it's okay. As I mentioned, for rotating equipment, it will be vibration accelerometers. It will be eddy current sensor depending on machine. It will be temperature sensors. It will be current sensors. It will be maybe pressure sensors if we are talking about reciprocating compressor, for example. For static equipment, this is mostly acoustic emission sensors, temperature sensors, and stress sensors. And
very good.
Also, extension. So all the we don't use only one method for diagnostics because each method have to be by different filters, which allows the system to identify a real source of problem. For example, for static equipment, acoustic emission, this is a sound which goes within the metal body. And it comes from different sources. It comes from the process. It comes from environment. For example, when we have sandstorm or rain, it will also affect. The problem, if you are familiar with acoustic emission, usually you make a test when everything is very quiet. Nothing happen around, and you just measure and you just hear and listening if there is some impulses. But our advantage that we taught our system to filter noise from environment and noise from the process, from the processing, from the noise, from the real defects which happened in the metal body, in the metal cells. And system identifies those impulses and monitors the clusters. So if the crack will be developed, system will identify not just the location of the crack, but the stage of development. System identifies 4 stages of crack development. This is passive phase source, active phase source, critically active phase source, and catastrophically active. Catastrophically active, it means that the crack is opened. So you can see it visually. But 3 other, you don't see any crack. You see just a wall. But system might knows that crack will happen here, and system allows you to prevent some opening. For example, some of our customers can weld pockets during operation without shutdowning the vessel, for example. If they know that here will happen, the crack will happen here, they just weld pocket on this place and cover this space. In another situation, for example, we are talking about crack on some vessel. You cannot use entire vessel, but you can fill out vessel up to this line where the crack happened. You can use particularly, so just part of this vessel, but you can continue operate it. So there are many different options. This is the reason why I told you that system doesn't provide how you should do that. System inform you what's going on, and you as an engineer have to I understand and have to perform some activities according to your experience.
Yes, I understand. Yes, very good. Okay, I have an issue here. I'm very open for this. Your advice about applying choosing a station, and I will give you the data sheet for this station to prepare a case study. That's very good point. But I have a question about for the static parts. If I'm talking here about a pipeline, Is there an option for a pipeline if I'm going to apply for a condition monitoring for the pipeline?
Depending on what pipeline. If in upstream, usually no.
Oh,
It's because you have very long length pipeline.
yes.
When we are talking about we are talking about pipelines within a facility. For example, you have two tanks and two vessels, and you have pipeline between them. We can monitor this pipeline because this pipeline, a few meters, maybe okay, 100 meters, but not kilometers. Because to be able to monitor pipeline, we have to locate sensors in each 5 meters. Each 5 meters. But if it is 1 kilometer, it will be not economically efficient. You know, you have for I would say mid and long distance pipeline, you need use another tools, not our system. Definitely.
Okay. Could you provide your webinar in another time at night after 10 p.m. on Cairo time?
It's possible, but tell me in advance when.
Yes, okay. I will let you know, of course, which day and if it's applicable for you, of course. But I have a maintenance manager, and he is free for after 10 p.m. for just for 1 hour, and of course in the morning he is in his office, but he's not able to be free for the webinar. So at night,
right now you are recording our webinar, correct?
yes.
So you can show him our discussion. You can show him our presentation, and if he has questions or he wants to discuss, of course I'm open. But you have to give me at least 3-4 days in advance because I have very tight schedule.
Yes, of course, I will let you know before it in a proper time. Of course, yes, I will do this.
Okay, so
the next step, the next step would be I will provide you for one of my equipments, one of my stations, with its data sheet, and I will make a schedule meeting with my maintenance manager, to have more detail and to have a good discussion about your system. And I think it would be helpful for the next step for
thank you, Hassam.
For what we can do. Yes.
Thank you, Hassam, and I hope to get your data sheet as soon as possible.
Yes,
because next 2 weeks I will be very busy. So if you could, because there are 2 conferences in Dhahran, Saudi Arabia. And yes, and if you don't provide it today or tomorrow, the next possible time when I can get back to you, it will be in June.
It's okay. I will provide you the details we talk about and the data sheet, and when you get ready for this, we can talk again with this. It's okay for me.
Absolutely, Hassam. So, gentlemen, thank you for your time. The only source you cannot buy, the only resource you cannot buy, it's your time. And I really appreciate that you spend it with me. Thank you, gentlemen.
Thank you,
have a
Mr.
wonderful day.
Thank you very much, Mr. Andrea. Thank you. Nice